All right. Hopefully you've gotten a chance to watch the video about going around the unit circle and how to identify the coordinates and angles, whether they're in degrees or radians. Today we're going to be moving around the unit circle and getting a little bit into it. So it's important that you have that reference for you, whether you have a printed out version of the unit circle that you filled in, or you can reference a filled out one either on the web or printed out. That way you can work through this, because at this point you probably don't have the unit circle memorized. So I want to talk about a term called terminal, and any angle that is opening on the unit circle has I think it's called the starting side and the terminal side. I'm not sure what that side's called, but that's not too important right now. So if you make an angle on the unit circle, usually we start at the x-axis on the right side, and we can go counterclockwise or clockwise depending on what the problem asks for. Typically we're going counterclockwise. That's kind of the default mode, and because that's the positive degree. So if I'm going counterclockwise, wherever that angle ends, that's considered the terminal side of that angle. And so if I say, all right, an angle on a unit circle, its terminal side is at 120 degrees, then what I'm really doing is I'm starting my side here, and I'm making an angle. 120 would be more than 90, so it would be over here. And 120 degrees, this side would be my terminal side of that angle. I'll keep in mind the terminal side can also be of an angle measured in radians. So it doesn't have to be in degrees. 120 degrees as radians, if you remember from a previous lesson, you would take that and multiply by pi over 180. And we can reduce 120 over 180 by dividing them and reducing the fraction. That's going to be 12 out of 18, and 12 out of 18 is 2/3. So that would actually be 2 pi over 3. So it could be a terminal side of an angle in radians, which would be 2 pi over 3. So a terminal side is just where the angle ends. Now you'll have a question: what quadrant in the unit circle does the terminal side of the angle lie? And you'll see some of the angles are in degrees and some are in radians. So I want you to write these down and give yourself some space to work these out, because we're going to draw a little bitty unit circle on each one. So if you need, a couple pieces of paper to work these out, that's fine. So I want to look at 200. The degree ones for me are less work because you don't have to, I think in terms of degree when I go around a unit circle. What I would do on this is just make an XY axis. And I want you to think about the degrees going around the unit circle. This would be 0 degrees, 90, 180, 270, and then we wrap it up at 360. So going all the way around, it's going to be 360. So 210 degrees is going to fall between 180 and 270. So what that angle looks like is somewhere around there. And it's starting here and opening up this way. That angle, that terminal side, that lies in this quadrant. Well, that's quadrant 3. So your answer to that would be quadrant 3. Remember, the quadrants are 1, 2, 3, and 4. What if it's in radians? Well, you can certainly memorize your radians. If you go around a unit circle and you break it up in terms of radians, not degrees, that would look like this. 0, pi over 2, pi, 3 pi over 2, and a full circle is 2 pi. So if you look at 2 out of 5, 2 out of 5 would be, well, that's less than 1/2. So it should be between 0 and pi over 2. But if you're a little bit confused on the fractions, we can take that and convert it to a degree. So I would, in this case, probably just take the 2 pi over 5 and multiply it by 180 divided by pi. Then you can take your calculator and multiply 2 times 180 divided by 5. And I don't know what that is off the top of my head. So 2 times 180 I know is 360. So let's pull up a Desmos calculator. And that would be 2 times 180 divided by 5. And the calculator says it's 72 degrees. So I'll write that. Now I'm going to make that angle. So 72 degrees is indeed less than 90 degrees. So it's going to be somewhere around there. That side of the angle is going to lie, of course, in quadrant 1. All right, why don't you try these 3? We'll see if you're right. You just want to set up your XY axis for each one so you can identify where in the unit circle that is. And I'll do E over here. All right, try C. Let's see what you got. 160 degrees. That's going to be between 90 and 180. So 0, 90, 180, 270, 360. So that angle should fall somewhere around here. Doesn't matter exactly where right now, but the terminal side of that angle is going to be right here, and that's going to be in quadrant 2. Pi over 3, that's 1/3 pi, should be between 0 and 1/2. We can convert that to a degree. We can do pi over 3 times 180 over pi. And if the pi's cancel out, then 180 divided by 3, 18 divided by 3 is 6, so that should be 60 degrees. So that's again in quadrant 1. 60 degrees, maybe about right here. And that'll be in quadrant 1. And this last one, 3 pi over 2. Making up the pi's, you can see based off letter B, I have 0, pi over 2, pi, 3 pi over 2 ends up being right down here. And if you look at that, that's going to be 270 degrees. We can do a quick calculation, but 3 pi over 2 times 180 over pi. Pi's cancel out. 3 times 180. Well, let's do 180 divided by 2 first. That's 90. And 90 times 3, 9 times 3 is 27. So that's going to be 270. And 270 degrees is right here, right on the axis. It's not actually in a quadrant. So in this problem, the angle will actually fall between 2 quadrants. So the terminal side of a 270 degree angle is actually, we'll say that's on the y-axis, not in a quadrant. So that's kind of a little bit of trick question there because it's not technically in a quadrant. All right, thanks for watching. The next video will be about rotating around the unit circle.